Let me resume the record. Okay, so let me share my screen. Meanwhile, they're joining. All right. So today we are going to discuss about that the very first module, that is the EIGRP. So we'll understand the couple of concepts like we have the link state routing protocol and we have the hybrid routing protocols. So basically we'll understand what is the link state and what is the hybrid, and one more feature, we have the distance vector routing protocols. So we have to understand like what is the meaning of the distance vector, what is the meaning of the link state, and what is the meaning of the hybrid, and why EIGRP basically known as the hybrid routing protocol, and OSPF as a link state and RIP as a distance vector. So that is one thing we'll understand. Okay, so I can see some people are joined, some are still not joined. Okay, let's start slowly. Meanwhile, others are joining. So whenever you think about the link state, so let me use my whiteboard here. So you might be going to get always questions during the interview. Can you just explain what is the key difference between the link state and which protocol is basically link state protocol, and versus you're going to get distance vector, and these are the two things you always going to get, might be when you're going to be the interview, they are going to be asked these questions, right? What is the link state, what is the distance vector, and subsequently they will also ask the hybrid routing protocol, means what is a hybrid routing protocol, why basically we called EIGRP as a hybrid routing protocol. So you must have to understand that is a hybrid routing protocols. Okay, so these three things will focus in today's class to understand step by step all. Okay. All right, so let's just start. Very first thing, what is a link state? So one protocol is going to be there in the link state. That protocol is known as the OSPF. Okay. And we'll discuss that. Distance vector pure routing protocol, that is the RIP, routing information protocol. Hybrid is going to be your EIGRP. So we are talking about the EIGRP and why this is known as the EIGRP. And let's understand what is the meaning of the link state. So just think about whenever you talk about link state. So take an example of GPS, means you sitting in any point of locations. Let's suppose you're in the router and you have a destination to reach this particular router R9. We could have the multiple path, okay, to reach this particular destination. But by sitting in this location, you have the full path visibility, means every road, every city, every alternate road. Just think about it, and even the traffic conditions based on the what is the my traffic condition when I'm going to start doing the travel from source to destination. That traffic condition is also going to be available with you. So it's a kind of the Google map, and this Google map have the end-to-end visibility of your path, and it will give the suggestions how and which path you should take to reach your destination in better way or faster way. That's why this is known as the link state protocol known as the OSPF. OSPF have this capability to just give the end-to-end all visibility. Okay. Now, what is a distance vector? I'm giving the brief, but we'll talk later on in detail what all algorithm is going to be used, how it is going to work. So when I will talk the OSPF, I will discuss again about this link state properties in very detail. But we're focusing on the EIGRP, so I'm just giving the brief. Now, when I talk about the distance vector protocol. So what is distance vector protocol? Distance vector protocol means you always have to trust on your neighbor. Okay. Means you don't have the end-to-end visibility of any destination. Let's suppose you are in the some city in New York and you have to travel some other city in the same US country, or maybe the India country, or in Delhi, and you want to travel in Mumbai. So you are going to ask your neighbor, hey, can you just tell me, means you are going to travel from one location, then you're going to ask your neighbor or friend, hey, how can I reach to my certain destination? Then he will tell, yeah, go through this path. Then again, you will ask how I can reach. Then you'll say, go through this path. So you are going to be always ask to your neighbors, who is your friend. So neighbor is going to be give the information, and it will tell the information how you can reach to destinations. So you don't have the entire map. You only know your neighbors, and based on the neighbor information, you can just doing the packet transmission from one location to another locations. So you just taken another example. Let's suppose you start doing the travel, and this is your origin point. This is your origin location where you want to start the travel. So might be very first place after your home, you're going to find the roundabout that is known as in India as a goal checker, and you have the multiple roads are going to be there. But you don't know, like you have a reach to some airport or railway stations. So you have the multiple roundabout in between, and you have the multiple paths. So whenever you're going to reach to one roundabout, maybe this is going to connect this way as well. This is going to connect this way as well. So you are going to reach in this destination, then you will check the vector. Hey, can you just tell me how to reach to this particular destination? So might be this vector is also showing that from this path you have the distance is 30 kilometer. From this path it's only 10 kilometer. So you will choose this part, then again reach here. It will say from this path you have the 5 kilometer, but from this path you have the 20 kilometers. So just follow this vector and go to destinations. So you have to follow the vectors, and vector science. If you just go and Google on the vector science, Delhi traffic road vector sign. So you're going to find like this one. Let me show you. These are the vector signs. You can see Delhi, you just follow this. You're going to get, like, if you want to go this particular location, just follow this road. So you're always going to every corner of your road, and then you are going to follow the vectors. And based on that vectors, you just go to your destination. That is known as distance vector. Means after traveling the some distance, you have to follow some vector. But link state having the entire map of your traffic, means end to end, whatever you want to do that, they are going to maintain your traffic. All right. Any questions, guys? Anyone have? Who joined a little bit late? I discussed about that key difference about the link state and distance vector routing protocol. So link state protocol is your OSPF, and distance vector protocol is your basically RIP, that is a pure distance vector, and EIGRP is going to be your what I can say, EIGRP is going to be your hybrid routing protocol. So we still have to discuss about the hybrid routing protocol. So I'll explain about that. Right. So as I mentioned that link state have the entire network topology, but distance vector having thus your neighbor information. And it is going to be used for the large network, but you have the small network, medium network, you can use a RIP. RIP rarely you're going to find in any network. Either you're going to find the OSPF or EIGRP or some other routing protocols. But yes, we have provision, we can use that RIP, EIGRP, whatever you want, we can use that. Now, if I talk about the hybrid routing protocol, so why hybrid routing protocol is going to be used? So OSPF, you know that the pure link state protocol, but why EIGRP known as the hybrid? The reason they maintain the property of link state plus they maintain the property of distance vector. So they have the both property in their routing protocol. That's why it's known as the hybrid routing protocol. What does mean? So if I'm talking about link state, that means earlier when it was designed, that was the advanced, it known as the advanced distance vector routing protocol. When Cisco originated this protocol, so original this protocol was belonged to Cisco. Only Cisco devices supporting this protocol. But later on, Cisco make as a industry standard, so other devices also can use this routing protocol. So it's no more Cisco proprietary. But when this protocol was built, right, this was originally designed as an advanced distance vector protocol. Later, it's become and known as the hybrid routing protocol because it's having a combination of feature, both distance vector and the link state. So what is the distance vector behavior? So the distance vector behavior, it always going to learn. They not have the LSA update. The LSA is not going to, like in OSPF, how you're going to be get the information about any destination based on the LSA updates. But in EIGRP, likewise in the distance vector protocol, you are going to get update from your neighbors, right? You not have the LSA who is going to be inject all the routing updates by DR, BDR, or might be the area or AVR. So in this distance vector routing protocol, we always get information from neighbor. So this EIGRP also always dependent on the neighbor. So learn route from the neighbor, and only the route I'm going to learn from neighbor, on this I'm going to trust. So that's why it's a property of the distance vector routing protocol. To learning route of the neighbor, that is a property of the distance vector routing protocol. In link state, they build the neighborship, but the routes are going to be updated by the LSH, and LSH is going to provided by DR. Sometime ABR is going to generate LSH. All neighbors are not going to be send the route information to neighbor router. No, in OSPF not going to be happen. They have some mechanism. We'll discuss about that. But here in distance vector and the hybrid routing protocol, it's depend on the neighbor. But RIP what they always maintain the tables based on the neighbor, whatever route they are learning. But what do the EIGRP do that? Based on the neighbor informations, they maintain the topology table. Means they are going to build the full topology tables, and based on that topology table, they will see which basically path is better, and they have almost similar kind of the map for the entire path, and based on that, they're going to just maintain the routing table to just process from one destination to another source or any source or other destinations. So this behavior is similar to the distance vector, that is maintaining the neighbor. And basically what they use one of the algorithm, that is the dual algorithm. And what is a dual algorithm? That is going to calculate your backup path. That is one of the feasible success. I'm going to discuss about that. So dual algorithm is going to be basically diffusing update algorithm. So let me write it here. We'll discuss after some time. So they use a dual algorithm, that is known as a diffusing update algorithm. And it is going to be core algorithm, and that is used by the EIGRP to calculate the best path and maintain the backup path as well. And it's also provide the loop-free convergence. So this dual is going to be help to make sure it's a kind of acting as a brain, and they are going to tell which route is the best for your destination. Do I have a backup route or not? How I can avoid the routing loops? And in case of any failure is going to happen for any path, do I have the backup path? Can I do the create the any backup redundant link connection to the reach destinations? So this is again dual, and this was developed. This algorithm was developed by the Cisco only. So in short, if you just even Google it, let me go on the Google and try to just search from the AI as well, and just ask why EIGRP known as a hybrid routing protocol. So you're going to get almost okay. So you can see this is talking about enhanced interior gateway routing protocol is known as a hybrid routing protocol because combination of the best feature, that is distance vector and the link state. While Cisco officially EIGRP in advanced distance vector, it was originally designed as advanced distance vector, and now it's become the hybrid because they maintain the characteristics both use the hope by hope updates. So updates are going to take from the neighbor. They not have the entire update from the LSH. So that is the only property they have taken from the distance vector. So neighbor is going to be always your best friend to get any routing updates. Now they, based on this update, they maintain the topology table. So that any topology is going to change, they're going to make the changes. And routing by the rumor, that is a distance vector. If you're going to heard about any term, what is routing by rumors? So routing by rumors, that means you always have to depend on your neighbors. You don't have source of truth. Means if I'm saying something might be the truth, but my neighbor is saying something wrong to you. So you always have to believe on your neighbors. But what is the original content? You never know. Like in the OSPF, they have the entire packet information. But in distance vector, they just do the routing on neighbor means a router does not possess the complete view of the entire network topology. It rely on its neighbor to advertise a network distance path. So that is the key concept. A link state characteristic, they discover the neighbor by the IGP hello packet, topology table, and all. So that's why they're known as the here distance vector plus link state, that is a hybrid routing protocol. All right. So EIGRP stands for Enhanced Interior Gateway Routing Protocol. And now you know that this is the Cisco proprietary protocol and widely used for the enterprise networking. And it's combined the best feature from the distance vector and the link states. That's why it's known as your hybrid routing protocol. So if someone is asking what is a hybrid routing protocol, you must know about that. What is a hybrid routing protocol? Key benefits, we have the fast convergence, excellent scalability, easy configuration. It supports any kind of the IPv4 configuration, IPv6 configuration, and VRF as well. They use like a lower CPU in compared to OSPF because OSPF have to do a lot of processing. They work on the LSA, right? Also, in EIGRP, you can do the load balancing, that is the equal load balancing and unequal load balancing. Other routing protocols, you cannot do that. Equal, you can do that, but unequal, it's very not possible. Even the OSPF, you cannot possibly can do that unequal load balancing. But yes, here you can do that equal and unequal load balancing. It's going to provide the low-free topology based on 𝗤𝗏. As we understand, 𝗤𝗏 is a diffusing update algorithm developed by the Cisco. And the key concept, 𝗤𝗏 is to find the best path, backup path, and avoid the routing loop. And in case of any failure is going to happen, that is also going to be used. Now, most important, the metric of the EIGRP is going to be composite metric. And we have to discuss about that. What is a composite metric? They use a value that like K1, K2, K3, K4, K5, and there is a K6 as well. So generally you are going to find K1, K2, K3, K4, K5. These are the metric parameter. Probably you are going to find in the upcoming slides. So K1, you are going to find the K2, you're going to find the K3, you're going to find K4, you're going to find K5. They are the normal value, but also we learn why we use a K6 as well. So there is a total 6 K values, and based on that, they calculate the metric. So we'll discuss how metric is going to be calculated. Okay. Now, problem with the RIP routing protocol, that is a legacy. They have the limited hop count. It means if you are using the RIP routing protocol. Any questions anyone have? I sense somebody is trying to ask something. All good. Sai, any questions? Okay.
No, sir.
All right. So let me mute yourself. All right. So problem with the RIP, that is a legacy routing protocol. So might be you guys learned the CCNA about RIP. So they have the limited hop count. The maximum hop count, they can go up to 15, and that is going to making unsuitable for the large network. If you have a very large and more than 15 hop count, so that is not possible by using the RIP. So that's why RIP is very, unused protocol if you have any large network connectivity requirement. So probably you can ignore this RIP. They also do the slow convergence. They have the simplistic metric, use hop count as a metric. So that is based on the how many hop count you have, that is going to act as a metric. And bandwidth west is also going to be there. So RIP having a lot of problem. And by avoiding this all problem, EIGRP come in a picture, and they use a dual algorithm, that is a diffusing update algorithm, ensure that my topology is going to be loop free and there is no hop count limitations. And they use the composite metric based on the K1, K2, K3 values. And by default, there is two bandwidth and delay is going to be by default as a your metric, but they can include reliability, load, and MTU. So total you have the 5 K values. One is going to represent your bandwidth, another is delay, another is reliability, another is load, another is MTU. So we'll discuss what is the bandwidth, delay, reliability, load, and the MTU. But by default, if you are not explicitly going to define that reliability, load, and MTU for the metric calculation, the EIGRP uses 2 parameters. Rest are going to be 0. Means your load is going to be 0, your MTU is going to be 0, and reliability is going to be 0. But we are going to use the bandwidth and delay. That means that is the default is going to be used. and they are going to just do all the matrix calculation. So we'll see how calculation is going to happen in upcoming slides. Now they will do the partial updates as well. Partial updates means whenever any changes occur in your topology. Let's suppose I build the full network topology, but suddenly any new routes has been added, any configuration change has been added. So they not do the full update. No, they just do the incremental update. Means whatever changes we made and whatever route we advertised, the partial update is going to be sent across the topology. So your entire bandwidth is not going to be utilized. Means maximum bandwidth is not going to be utilized, just limited bandwidth is going to be utilized. That's why they use the incremental update concept. So this is the core component of the EIGRP. And as we mentioned that dual algorithm, we have to discuss this, the basically a nervous system, brain of the EIGRP, heart of the EIGRP, whatever you can think. Without this dual algorithm, you cannot run the EIGRP all concept. It means whatever you want to do the backup path, base path, loop-free topology, and you want to do the failure direction, this all possible via the dual algorithm. So dual algorithm is the diffusing update algorithm. That was the core algorithm used by the EIGRP, and this is developed by Cisco only. Okay. And this is going to ensure your topology is going to be loop-free topology, right? Fast convergence, and it's maintain the topology table in each EIGRP. Like it identify the backup routes, select the best route, support the VLSM, and handle the any route failure is going to happen. That's going to give the backup path as well. Now, also in EIGRP, when we are going to do the configuration, we are going to find neighbor tables, topology tables, and routing tables. There is three tables are going to be there. So what is a neighbor table? Neighbor table is going to store about your neighbor informations. These are the neighbors. So neighbor table is going to be store your neighbor informations. Like it's all neighbor information. Who all are my neighbor? I will show you how to check the neighbor table as well. Topology table is going to consider all possible route from the neighbor. This is your RIB, right? Routing information base means collection of all possible route. So that is your topology table. Routing table is a fib that store only the best route. We discussed yesterday enough. That's why this is the reason I discussed the study sessions in very detail. So you guys must be aware what is the RIB, what is the fib, and why we are using the RIB fib informations here. So that is a neighbor table, topology table, and routing table. Three tables you are going to find in the EIGRP, and based on these tables, you are going to get like whatever you want to do the routing configurations, you can do that. The EIGRP recommended dual, right? As we have to process the anything through the dual, so neighbor discovery, reliable message delivery, and ordered wave processing. That dual is going to maintain, and that is going to make sure you have the loop-free topology. So again, dual is going to there. Now, if I'm going to configure the EIGRP, there are some timers as well. Okay, so give me 1 second, guys. 1 second. 1 second, please wait. Sorry, guys. So I was talking about the timers of the EIGRP. Means whenever going to do the EIGRP configuration. So if you have the Ethernet circuits, like any Ethernet, 10 gigabit Ethernet, might be the 100 gigabit Ethernet, right? Even the 1 GPS Ethernet, even more than that. They use the timers, hello and hold timers. Means if I'm going to build the EIGRP neighborship, what does it mean EIGRP neighborship? That means let's suppose this is my one router and this is my another router. So I have to go and define the EIGRP neighborship. So EIGRP neighborship is going to define. So they must have to keep sending the hello packets after 5 seconds. If I'm not going to receive any hello packet till 15 seconds, I will consider my neighbor has been dead. So let's suppose what is going to happen. Let's suppose this is your topology. R1, R2, and R3. This is going to connect with the R4. R4 having one of the subnet 4.4.4.4. We are running the EIGRP. The one route is learning from here. That is the 4.4.4.4. Another is running from the here 4.4.4.4.4. But let's suppose this matrix is low matrix. I will discuss what is the matrix, how this matrix is going to run, and there is a high matrix. So in RIB table or in the topology table, RIB or topology table, we are going to get both route. But this one is going to best route. This one is going to best route. So if somehow this neighbor is going to be dead, he is not responding till 15 seconds. The timer is very important. If you are not going to receive the 15 seconds, it will remove this route tables, means best routing is going to remove for this neighbor, and the new best route is going to be available from this path as well. So this is the backup path calculations. So they maintain the backup path, and in case of any failure is going to happen, means you are not going to reply always within the 15 seconds. I consider my neighbor are no longer available and I can change my routing decisions. That's why EIGRP default timer are most important. Similarly, if you're using any multi-point link like frame relay, ISD and BRA, they have the different timers. They use the 60 seconds and 180 seconds. So based on this timer, means if you have the slow links, they wait more, it means they wait up to 3 minutes. And if you have the high speed link, like you have the Ethernet and all, they can just go and do that for the fast pace. Clear, everyone? This one is clear, right? If you want to modify this timer, you can do the modifications. Let's suppose you want to make 1 second, 3 second, 3 second, 9 second, like that. Any time you want to modify, this one also you can modify, but these are default timers. So you guys can note this down. It's going to be huge. Now, if I talk about the EIGRP is going to use the multiple packets whenever you're going to build a neighborship. So if two routers are going to build a neighborship, let's suppose this is my one router and this is going to my another router, and I want to run the EIGRP. So they use the multiple packet, like they send the hello packet. This hello packet are going to contain some information. Then they are going to get the update packet. Then there is a query packet. Then there is the reply packet. And then we have the acknowledgement packet. Total, we have the 5 packet in the EIGRP. And based on these 5 packets, we are going to form the neighborship in the EIGRP. So if you want to form the EIGRP neighborship, you must have to understand these 5 packets. What is my hello packets? What information is going in the hello packet? What is my update packet? What is my query packet? What is my reply packet? And what is my acknowledgement packet? Most of the time, if you're going for the interview, people are going to ask these all questions. Can you just explain what is inside of the hello packet and why you need the hello packet? So hello packet is the first packet whenever you want to start doing the EIGRP neighborship. So the moment you are going to configure EIGRP on the router interface, right, it will join one of the multicast address 224.0.0.10. And here also you are going to send, means configure the EIGRP. This will also join this multicast group. So multicast group is means we are in the same family. So if I'm sending something, someone is going to listen to me because we are in the same multicast group, same multicast family. So if I'm going to send something, somebody is listen to me as well. So that's why they are going to use a multicast. So the moment you configure this hello means EIGRP, they will send the hello packet and somebody is going to listen to me, and this hello packet is going to contain most important value, that is the AS number plus K value. As I mentioned, we have the K value. AS number means whenever going to configure the EIGRP, you have to define the autonomous system number, and then the K value is basically your K1, K2, K3, K4, K5 and K6 value. We'll discuss later. After this slide, you're going to find that. So understand, these are the 2 important things they're going to carry along with the subnet details. And if you have the authentication configurations, so these parameters are going to be there. And if all are going to match by your neighbor, I mean, let's suppose I'm listening here, I'm in the same multicast group. You're sending hello and you're sending this all 4 information. And if matching to me, then I will form a neighbor. And definitely I will send also my detail to you, and if it is matching to you, then only you form the neighbor. Means we understand we both have the same information, and that's why we are the going to be neighbor. And if you not have the same information, we are not going to be neighbor. Yes, Siva.
So what is our ASN?
ASN is an autonomous system. Autonomous system. So AS is basically means every organization they have the AS number. So might be you have the one company, they have the AS number. AS number is a unique identification of your organizations. BGP use this AS number and also used by the EIGRP. So it's just your organization is going to use the special value, that is the AS number, just for the unique identification. So what is ASN in EIGRP? So you're going to find this. So autonomous system number, the numerical value use the groups that used to group a set of the router under a single administrative domain. Means your organizations that is going to use any numeric value, unique value. So let's suppose my company is SCL, my company is GoInert. So I'm going to design one of the AS number for my company. That is a numeric value. This numeric value is going to belong from this range. From any IP, you can use from the any number from this range, like 1265535. So you can use any value. That is your AS number. Clear? And this AS number must be matched to your peer as well. Means whatever you have peer, that is also going to match. Clear, Siva?
Yeah, and the multicast, is it the standard one, or we can
Yes, it's the standard one. It's a, you have to remember this EIGRP multicast IP address as I show that. So you have to remember this address. This is for the IPv4, same thing in the slide as well. So always when we're going to configure EIGRP, for similar for the, we have the 𝗲𝗶𝗃 as well. BGP not use the multicast, but 𝗲𝗶𝗃 also they have the .5 and .6. So we'll discuss later 𝗲.5, 𝗲.6. And but EIGRP use this multicast address. So whenever going to configure any EIGRP, primarily they carry these all value. And if these values are going to match, note my word, then only your EIGRP is going to form. And most time people are going to ask, what is inside of the hello packet of the EIGRP? In interview, if you go that, they will ask, hey, can you just tell me what is the inside of the hello packet of the EIGRP? So you should able to answer that. There is an AS number. What is AS number? That is a unique identification of your organizations. The number could be 1265535, right? The K value is the K1, K2, K3, K4, 5, and 6. We'll discuss what is the key value in detail later on. Subnet details and the authentication it is available. So that is the your hello packet. Now the second packet in the EIGRP is the update packet. So hello packet is going to be always generated whenever you want to send the EIGRP. When you want to configure the EIGRP and you want to build the EIGRP neighbor, the hello packet is going to be always there. But they use the update packet as well. What is the update packet? Update packet, let's suppose I have any new route update, or let's suppose I discover any new routing update. So that routing information must be going to process to other routers as well. That's how you can see, send a new route discovered, a network become unreachable, right? So that route might be going to be removed. So that also I need to update. Or routing matrix change, that also means any route matrix some change. Any query packet are used to ask routing updates, means anyone asking routing update. Any request means any router just add new routes. So deleting the route means mistaken, you remove any subnet, link is get down, your matrix change, your query generated for the route. Any request for the update means anything you want to make change in your topology, EIGRP never say. That all is going to happen from the update packets. So it is going to send if any kind of the changes is going to happen in your topology, that is going to be use the update message or update packet to just make sure everyone is aware about that. Okay, that is your updates, means any kind of changes is happening in the topology. Now, what is the query packet? Query packet is something, let's suppose I lose some route informations, right? And I want to get information about that route. So it is going to send to the neighbor when route doesn't have the feasible successor for the route. Means what does it mean? means technically you lose route and you don't know what is a feasible successor, right? So you don't know feasible successor, so just hold down for time. Just understand the query packet. It is going to be used if there is no route available, means some route you have earlier, but you lose the route and you're not getting reply from your main origin. So you're going to just send the query to other neighbors. Say, do you have this route informations? If they will send, then they will build the new topology, and from there they will find the new successor to just go on the destination. But if there is no route, then probably they will simply drop the packet. So that is going to be a query packet. Reply packet, if any query is going to be there, based on the query, you're going to get a reply. And then acknowledgement, like if you have any update query reply packet, so based on that, you're going to get in the acknowledgement as well. So if you ask what are the packet type in EIGRP and their roles, you're going to get the similar definitions. So you can see that we have the packet type. Hello, like it's going to be always send updates, right? And then we have the acknowledgement query, and that is so hello package. Basically, it's going to be used to discover your neighbor, right? And they use the certain values, key value, AS number, subnet detail, and that your authentications update. If any topology change happen, means anything happen, means any used to transmit actual routing and topology information, means any topology changes is going to happen. They use that update packet to just update that. Acknowledgement, that confirm, means whatever the update query we have, any packet is sending update query or reply, that you just getting an acknowledgement. Yes, I received that all information, so I acknowledge that. So yes, there is something reply is coming from my neighbor, so they are aware about that my all update query and reply. And the query packet role, send the router lose the primary path, means I mentioned that if they lose the primary path, then it will try to find the second primary path by sending the query to the neighbors. So that's why the query packet is going to generate it, and reply is basically based on the query who all neighbor are available. They are going to be just give your informations. Okay, so this is going to be your 5 packets. So always remember there is a 5 packet, and this based on that 5 packet you are going to be build your EIGRP all table and routing information. Any questions, guys? Anyone have? I believe it's a self-explanatory and it's good for everyone. Yes, Siva?
So the query packet will be sent only when the primary link is down, right?
Yes. And if you don't have any kind of the backup link available, feasible successor, you don't have any path to go to destinations. Let's suppose you have the only one path available and that link goes down. So you don't have feasible successor, means you don't have the backup path. So it will try to send other neighbors. Do you have the informations? So if you say yes, I have the information, then based on that, they will recalculate the path to go there. If no, then simply it will drop the packet.
Okay, sir. Okay, good.
Okay.
Thank you.
All right. Now, so
I have one doubt, sir.
Yes, Amrita.
In hello packet, it will send multicast packet, but the reply packet either it's unicast or it is multicast.
Yeah, so reply packet is always going to be your unicast. So I forgot to mention that. See, reply packet is unicast always. So hello packet is multicast. Update is also going to multicast, but acknowledgement is going to be unicast and reply is also going to be unicast. I just forgot to mention that. So anything reply is coming, that's going to be always unicast, Amrita.
Okay, thank you, sir.
All right. Means any acknowledgement means you sending something to me. So I know who is sending to me. So I'll reply to you only. If any reply is coming, always going to be unicast. Any acknowledgement is also coming, that is a unicast. Rest hello is multicast, means who all are listening to me, that is the multicast. Basically, update is also going to multicast, right? And your query is also going to be multicast. Now, if I talk about the EIGRP packet details, so again we discuss about that use neighbor discovery relation. This all we know that they use the this multicast address. They contain the multiple critical parameter configuration parameter. We can enable on the multiple interfaces by using network commands. Hello packet contain these all informations like we discussed just now, and query reply already we discussed. So okay. So I believe we are good for the basic fundamental EIGRP. Initially, we are good with this, right? Now we have to understand Okay, so we have the deeper concept of the EIGRP. But before going the deeper concept, let's do some labs testing how these all hello packets are getting generated. So we'll do the debug in all and we'll see what is going to happen in the routing and how this all packets are going to be generated. So let me go here and configure some labs. So we'll see the packet informations and we'll see some kind of the other parameters. So let me use this EIGRP. So yesterday we configured this lab. So I will turn this lab. And now we are going to configure this entire lab based on the EIGRP. So there's a 𝗲𝗶𝗴, EIGRP is running in upper side, 𝗲𝗶𝗴 I believe below side. So we'll configure end to end is the EIGRP. So this is my R1. Sorry, R3. This is going to be my R5, R4, sorry. This is going to be R5. Okay. Okay. So if I go in the R5 router, show IP protocol summary, if you want to see which protocol is running on this router. So you can see we are running EIGRP on this router. This is running the EIGRP. If I go the R3, if you want to check what all protocols. So see, connected is going to be always there. Static is always there. Application is there. But these three are by default, you're going to find that. But for the EIGRP, you're not going to find any static route here. See, there's no static route, but you're going to always get these three output by default. But dynamic routing protocols, anything for dynamic routing protocol like OSPF, you want to do any configuration for BGP or RIP, ISIS, you will get as a this output means EIGRP with process you are running means AS. This is AS number of the EIGRP. If I go for this R3, it will show protocol summary if you run that. See, this is showing that apart from these three protocols, we are running the OSPF and 10. This is not AS number. OSPF is process ID. So process ID is different thing. And EIGRP AS number is different thing. Both are not same. So I'll explain what is the process ID and what is significant of the process ID. Likewise, for EIGRP, we understand that. And if I go for this one and try to show IP protocol summary, so you're going to get that again. We're running the okay. Already we checked that. Go in the R4. Show IP protocol. We are running the OSPF. Summary. We are running the OSPF and R6. We are running the both. Okay. So what I'm going to do that I'm going to disable the OSPF from these links. Okay. This is the first thing I will do that. So let me go and disable the OSPF. So show run section OSPF. Okay. So I configure the OSPF on the interface. That is my Ethernet 0 here. And show run interface Ethernet 0/0. And one is going to be loopback 3. Okay, so I want to remove this. So I will use the interface range command and I will use ETH 0/0, loop 3. And I will use the okay, so this is the OSPF. So I'll not commit, I need to use the write. So we lose the OSPF and if you run the command show IP protocol summary now. So you still have the OSPF. Why OSPF is there? Okay, router OSPF is confused. Let me remove this router OSPF. This is in the global routing. So let me remove. So there is no routing protocol you're going to find. Sorry. See, only now we have the EIGRP. So EIGRP 100, OSPF has been removed. Now I'll go in the R4 as well. So R4, we have the OSPF running on these two interface, Ethernet 0 and 1. So let me go directly remove that. Config T, interface range, Ethernet 0 by 0 to 1, no IP OSPF, 10 area 0. Okay, let me show run section OSPF. Yeah, so let me remove the no router OSPF 10 from the global and show IP protocol summary and write. So we are not running any protocol here, right? Now let me, because EIGRP is running only this is the neutral router, just OSPF was running. Now we remove the OSPF as well. Now I'll go in the R6. R6 apps are going in the R6. R5 we don't have any OSPF, so we are good. Now show IP protocol summary. R6 should have the OSPF. Yes, we have the OSPF. So config T, interface range. We have the two interfaces which are part of the OSPF. One is the Ethernet 0 and the loopback 6. And no IP OSPF 10 area 0. And then no router OSPF 10. And show IP protocol summary. We're not getting anything. Now we're good. So moving forward, if I want to go on the R4, and after I want to go in the R4, I want to configure the EIGRP. So we'll see what is the behavior is going to happen. So if I just see, if I enable the debug on this router, right now you can see in this, I configure the EIGRP. And to configure the EIGRP, I use some syntax. What is this syntax? Let me do configuration step by step from the scratch. Okay, so let me remove everything from R3 point of view, and we'll do the configuration again for R3. So there is no configuration in the show IP protocol summary, and we'll see what is going to happen. There is no protocol configured for the EIGRP. And if I show IP EIGRP neighbor, we don't have any neighbor as well. So very first thing, when I'm going to enable the router EIGRP on this command, we'll see what packet is going to be generated by default and what the multicast address is coming or not. So what I'll do that, I will generate the command debug IP EIGRP. Let me use the neighbor. Okay, there's no packet, debug EIGRP packets. Okay, so let me packets, all packets are going to be there. So see, your packets are generated. Okay, now let me start the debug. Let me see what all option EIGRP neighbors. Okay, neighbors. So okay, that's to debug. I enable it. When debug is going to give the detailed log, what is happening after running the certain command. So I enable the debug only, and I'll enable the debug on the R4 as well. So we'll see that. I'll go in the R4 and debug EIGRP packet, debug EIGRP neighbor. Sorry. Now I'm going in the R3, and after going in the R3, I will go here and run the command. Very first thing I want to configure router EIGRP. So I'll go router. The command to enable any routing protocol, you have to mention the router EIGRP. Means anything. It means any routing protocol you want to configure, you have to give this syntax router. I mean, this is syntax you have to configure on your router, and then you have to use the BGP, EIGRP, ISIS, any protocol, OSPF, RIP. So we are going to use the EIGRP. Then it will ask, you have to give the AS number. This AS number can be two type. One is the number, one is your name as well. So we'll discuss when we are going to use the named base EIGRP configuration. But right now we are configuring the number base EIGRP. But later on we'll see that how we can configure the named base EIGRP as well. So in this number base, I'll put the AS number, any number. Let's suppose I want to use the 100. So this is my AS number. This is the autonomous system. This is a unique for my organization. Any number you can choose. Now done. Now, after that, I will define the network on which I want to enable the EIGRP. So I have a two network. One network is this one. So if I go here and you see this network is considered as a 340.0. Sorry, let me put it here. 0.0.0/24. This is your one network. And for this one, let me put for your reference, this network is basically going to be 35.0.0/24. This is another network. And if you go for there, you go here and you just give the network is going to be 46.0.0.0/24. You can give the network. And if you want to go for here as well and give the network as a 56.0.0.0/24. And you want to give some kind of the style, you can give that also. Okay, let me use that. You want to make your topology a little bit good, you can do that. Okay, already done. So we have this networks, right? And this is a loopback. So if I want to enable the EIGRP, so I need to define these two networks, 34.3 IP here, .4 IP here, 35.3 here, .5 here, 46.4 here, .6 here, 56.5 here, .6. So this is the IP schema we discussed yesterday and I deploy that. So if I hope everyone know that how to define the IP and all. Now, if I want to just assign the IP address, means the network on these two subnet on the EIGRP. So I'll go here and use the command, the network command. Under network command, I have to give this first 34. So 34.0.0.0, and then they will ask the wildcard mask. So wildcard is just reverse of your subnet mask. So subnet mask is 255.255.255.0, means there is a total 24 bit is going to be on, 8 bit is going to be off. So wildcard is going to be make 24 bit off and last 8 bit on. So this is your wildcard. So this is syntax you have to give and just give the network command. See, the moment I configure this network command, you see the hello packet has been sent. Listen guys carefully. See here guys. So you see the moment I configure this network, you can see this is start sending the hello packet. See, so this is trying to send a hello packet on the multicast group that is going to be your 240.0.0.4. So this is trying to send, but nobody is listening. Even you see this router is not listening anything. So it's trying to send the hello packet. Let me try to debug IP EIGRP show the even the. Okay, let me use this 100. So let me see what is happening. It's still sending the AS number 100. I want to see even the notifications. Okay. Neighbor is no neighbor, right? Neighbor address is not available. So okay, we'll see that. But it is going to show even the debug address as well. But right now it's saying that debug means your hello packet on one single interface, because this interface we enable the EIGRP. Now I'm going to enable the EIGRP for this interface. So you will see this is also start sending the EIGRP packets. Muhammad Hussain, any questions you have? Muhammad Hussain? Okay, let me mute him. So I'll configure again. Okay.
No.
Sorry, Muhammad?
No, I'm okay, sir. Thanks.
Okay. Okay. Now router EIGRP 100. Now I'll go and configure the another network again. This is going to be my 35. Yeah, this is going to 35. So you'll see after this 35, now you see you have the lot of details here. Let me unstop all. You can see here we start getting a lot of packet. So you say start sending the hello packet. I stop the my debug now. So the moment I configure the EIGRP, no router is listening right now. See, this is not connected as of now, not doing anything. Even if we enable the debug call, if you want to say show debug, See, the debug is on here, but we're not seeing any kind of the information. Even let me or debug IP EIGRP, and I'll give the AS number 100. We'll configure the AS number. So we'll say show debug. So you see this all debug is on, but I'm not receiving. But you see here they are sending the debug hello packet, they are the IP address, but nobody's replying, nobody's replying, nobody's replying. And by default, this is your router ID. Route install save with router ID because loopback is. Yes, Siva, please go ahead.
The AS number has to be same for the source router and the neighbor router, or
As you discussed now, to build the neighbor shape, hello packet must have the same AS number. If there's AS number different, they will not form the neighbor shape. To build the neighbor shape, you have the 4 parameters in the hello packet: AS number, key values, and the subnet detail, and that is the your authentication. If all is going to be same, then only you're going to build the hello packet.
Okay.
Okay. Okay. So now we have this configuration and we're sending the hello packet, but nobody is receiving the hello packet, right? So let me again do the debug EIGRP. Let me on this.
Sir, I have one more doubt.
Please go ahead, sir. Ask your question.
Sir, actually, while we are, for example, from the ISP, while we are taking the public IP, they give us the multiple subnets. In that case, how we can match with the AS in the subnet mask?
First of all, we have to understand that question is valid and this can be also doable, but I want to ask one question. EIGRP, OSPF, do we really use for the ISP? What do you guys think? It's a good question. So just for the clarification, are we going to use the EIGRP, OSPF for the WAN or it's a LAN?
LAN.
LAN. So that is not valid, right? So even you can use the EIGRP in the WAN for some scenario, but yes, generally we use the LAN. So LAN always having the multiple subnet, but they have the same AS number. Now your question is, let me draw your questions for the better understanding. You're saying that you have the ISP, right? And they're giving the multiple subnet to you. Is it like that?
Yeah.
So let's suppose they're giving the multiple subnet 10.10.10.0/24 172.16. So what is the question?
The question is, we received the /24 as subnet mask. So like that, they have a multiple, like there are multiple clients, multiple subnets are there from the ISP. So in that case, AS number, how it could be matched?
AS number for your ISP is going to be same always. It's not going to be different. Any ISP sending the any public IP to you, they have the public AS number, and every ISP have the unique AS number. That is going to be same. So whatever the subnet they are sending doesn't matter, but AS number is going to remain same. So whatever the branch, whatever site you're going to connect, they're going to connect the same. We'll discuss this in the BGP, okay?
Yeah.
How this is going to build. So AS number not going to be changed. Because this is also representing one organization. Airtel is one organization. They have the one AS number. Okay. Okay. Now let me go here and we'll go and configure the router EIGRP. He is keep sending the like AS number means hello packet, but no one is receiving that. No reply is coming to him. But we'll see after configuring the router EIGRP and enable the network. What is the network? Network is going to be 34.34.0.0. And we give the wildcard. The moment I will enter this network command, you'll see this temporary logs are coming, just sending these 2 ports. You start replying back some packet on the Ethernet 0/0 because we are configuring for this interface. So I will just hit that and see. You can see, let me do the you all. Okay, let me stop this. Let me stop here as well because we are done. Let me stop that all AS number. Let's read this message. See, the moment I'll send this, enable this network, the hello packet sent on this particular link, this Ethernet 0x0. And based on that, we receive some informations, and based on that, we have some update packet, hello packet. You can see there are different packet. Neighbor change, neighbor SIP has been built. You're getting the update packet, acknowledgement packet. You can see here, there is no query, and there is no, what was the one more packet type? One was the query, one is the update, and acknowledgement. I forgot that one more packet type was there. Anyone able to remember? Yeah,
Reply.
update, reply, yeah, reply. So you're not getting any reply, but you can see 3 type packet are getting. Acknowledgement we are getting, right? So just their acknowledgement update. So packets are coming, and only we left with the multicast group, but they are going to join the multicast group only. We know that. So I need to check the debug command for that multicast. So we're going to find that also. So you can see whenever you just enabling the neighbor SIP like establishment process, they are start exchanging the hello packets, and then they build in the neighbor SIP. So every router is going to do the same thing. So now if you check here, show IP EIGRP neighbor. So you're going to find you have one neighbor, and this is the neighbor. And if you want to check the details, you're going to find these details. Meaning this is the EIGRP neighbor, and you can see hold down timer 11 seconds. It's keep changing. Uptime is this one, and there is a RTT value, like how many milliseconds they're getting by 5, and topology change means nothing changed till now, just building. But for the R3 point of view, if you check the show IP EIGRP neighbor, you're getting the 2 neighbor. Why 2 neighbor? Because this is also already configured. In this R5, we have the already EIGRP configured. That's why they build the neighborship adjacency. So you can see this R5 is already running the EIGRP, and if you run the command show EIGRP neighbor, you see there is a 2. So you can see this is the your EIGRP neighborship. 2 things. All right, so we have the neighbor, this is the neighbor. Now R6 already have the configuration, so you can find the R6 also as a neighbor. Show IP EIGRP neighbor. So as I mentioned that we have the multiple tables as well. Packet we know that, and we also that answer we have the 3 tables: neighbor table, topology table, and routing table. So this is the neighbor table. If you want to go and see the neighbor table, you have to run the command show IP EIGRP neighbor. So that is going to show your neighbor table. And if I want to say the routing table, you just have to run the command show IP route. So this is going to show your routing table. D is going to represent your routing informations. Any D. So you can see this D is basically representing this route is learning from the EIGRP. Okay. EX is going to be EIGRP external. There is a AX as well. So if you're saying any kind of the AX route in EIGRP, that is going to represent external route. So we'll see what is the meaning of the external, how it is going to be external as well. I will do this all lab testing later. So D is just representing, yeah, and this is the metric, not metric, AD value. This field is your AD value, and this is your composite metric based on the K1, K2, K3, and K4 values. So we'll discuss how this composite metric is going to be there. Okay, Siva, what is your question?
So the EIGRP is applying only on the interfaces or on the global routing as well?
It's a global routing. We're not applying on the interface. We apply on the global only. There is no interface level configuration for the EIGRP.
Okay, sir.
You can check it. So
the one mentioned here, like either at 01, 01, 02.
That's gonna router. Say like IP OSPF you have, but IP EIGRP you not have any questions, right? OSPF you can do the interface level, but EIGRP always is going to be in global level. So if you see here, show run section EIGRP, we have this global level configuration available. So we have the neighbor SIP, we have the routing table. Now, if you want to check the topology table, show EIGRP topology. So sorry, show IP EIGRP topology. This is going to show your all topology table. And in this topology table, you can see there are some successor FD, successor FD, successor FD. So what is successor? What is the FD, feasible distance and all that also we have to understand. So this is known as your topology table. You can see these are the P route. P means that is a passive route. Passive route is basically known as the valid route. If your route is showing active, that means it is your invalid route. In EIGRP, you see my route is showing active. That means it's invalid route. If your route is showing passive, that is going to be your valid route. So take a note. So in neighbor table, you don't have such information. So you only have this information, flag and all. But in your topology table, you're going to see all possible route for all destinations. But you are going to get who are basically passive, who are the active routes. So that is also very useful. And you can see there's FD, successor, and feasible successor. There are a lot of differences are going to be there. So we'll discuss that as well in later stage. So we understand the neighbor table, topology table, routing table, and also we understand how these messages are going to be initiated and how to enable the EIGRP. So whenever you want to enable the EIGRP, you must go in the router configuration, and after that you have to enable the EIGRP configuration in the routing table. All right, so now moving to the second module. Okay, second module for the EIGRP, we have to understand how this EIGRP is going to be calculate the path. So we have the successor. What is successor? Yes, Amrita?
I have one doubt, sir. In EIGRP, by default, hop count is 100. We can maximize up to 256. Do we need any special additional license kind of things to maximize count? Increase the maximum hop count?
No such license is needed. There is no special license needed, but let me check it. No license needed for by default iOS support that. Okay. Yeah, GRP max hop count and how we can increase, because this is first time you're asking. This how 100 is also going to be to increase hop count. This is this command you need, maximum hop count command. So
Yeah,
you go in the configuration, router EIGRP, and put this metric maximum hop count. So you have to use this command, router EIGRP 100, and then we have to use this metric maximum hop count, right? 250. So there's no license special needed. But we don't need this metric definitions because they use the composite matrix, and 100 hop counts are too much. There is no network available for the 100 hop counts across any connections. Okay.
Okay.
Even you're traveling any country to any other country, probably you're going to find 5-10 hop counts, not more than that.
Okay. Thank you.
But you can just configure that. No problem. Okay, so as I mentioned that we have the successor, and what is successor? Let me open the book as well. So we'll have some kind of the, so we are talking about the EIGRP. Okay, this is the EIGRP. So you guys can learn this in the ebook as well. So this is the autonomous system. This autonomous system is just representing your boundary. And this can be AS200, 100. So within the same autonomous system, you can form the EIGRP neighborship. And different AS number, if you want to form, it is not possible. We can make them communication, but you have to build the AS number. Same router can have the two autonomous system, but you have to configure in the different way. And this is the terminology. You are going to get that successor, feasible successor. So we have to understand what is successor and what is a feasible successor, and why successors are needed and why feasible successors are needed. So see,
sorry, can you please show me the previous diagram, AS100 and AS200?
Yes.
Okay.
Yeah.
Thank you.
Clear?
Yes.
So we starting this fundamentals, and before talking anything in book, they're just talking about they're using the dual algorithm. They have like property of the hop count metric and the link state metric. They are talking about the autonomous system. Then suddenly they are talking about the EIGRP terminologies. That they are talking about the successor, feasible successor, your feasible distance, reported distance, feasible conditions, and feasible successor. Successors, feasible distance, reported distance, feasible conditions, and the feasible successor. These are the key things we have to understand. So what is a successor? Successor is nothing, a best route to reach any destination. So you can see successor is the best possible route to reach any destination network. So if you see in this particular output, if I go and run this one, show EIGRP topology table, show IP EIGRP topology. So you can see if I want to reach particular this 6 prefix, this is the successor. Successor is 𝗵𝗃𝗃𝗃𝗃. This path is best to me to reach my destination. This has become my successor. So successor is nothing. Successor is the best possible route to reach the destination. EIGRP always use successor route forward the traffic, right? So giving the analogy, imagine you want to go to your home to office, you check Google Map and show the 3 possible route. The fastest sorted road is your successor. Means whatever the shortest road you're going to find, that is a successor. Means the best path to reach the destination, that is a successor. So if anything is going to use the successor, that is the best possible route to reach the destination, that is a successor. Now we have the another term, that is a feasible successor. Feasible successor is your backup path. Let's suppose you have the one path that is successor. Now, if you want to go for your backup path, let's suppose you want to go for some destinations as your backup path. So your backup path must be available to go that destination. So that backup path is known as a feasible successor. In case of my successor is going to fail, then feasible successor is going to be available, and that feasible successor must be loop free. That is going to be done by the real-time dual algorithm that is used by the EIGRP. So the feasible successor is the backup route of the EIGRP, ready in case the main route, that is a successor route, get failed. So that is immediately available to just send the traffic. So that is your feasible successor. Clear? So 2 terms, successor versus feasible successor. I hope everyone clear. Give me thumbs up, guys, if you all are clear about that. Successor and feasible successor. Okay. Now, moving forward, we have that is the alternate route. We have the next thing, feasible distance. There is a feasible distance and also known as the reported distance, travel time, or you can just think about how much time I need to travel from one location to another location. So feasible distance we have, and we have the feasible conditions as well. So reported distance, feasible distance. So feasible distance is basically total metric, total travel time. Just let's suppose if I am in the one location and I want to travel to another location. So how much total time, total cost, total metric I will take to reach that destinations. That is the feasible destinations. So feasible destination is a total cost metric for the EIGRP route to reach the destination using the successor route. So that's why you can see in our table, we have the feasible distance. FD this is the metric. For this route, if you are reaching that, this successor route, through that, if you are reaching that destination, your feasible distance is this. Means this is your metric, right? This is your metric to reach that particular destinations. So that is your metric, and based on that, you can reach to the destination. So feasible distance is nothing, it's a metric, best metric to reach your destination. Clear, everyone? What is feasible distance? So feasible distance is total cost metric of the router to reach the destination using the successor. And this is going to calculate based on the key values, K1, K2, K3, K4, K5. Clear, everyone? What is the feasible distance? Everyone, I want to make sure you understand these all things, parameters. Okay, so I'm just considering you all are good now. Yes, Amrita?
Can we manipulate this feasible distance, like if we reduce the link bandwidth?
Yes. So we can do that.
So how it react in that time? If
I will show in the configuration. Wait for a while, Amrita. We'll see how to change the event metric, how to do this all calculation. But understand first of now the concept. What is the meaning of these all terms? Then we'll discuss about that.
Okay.
I will do in the lab. Okay. There is a
Okay.
lot of things we have to do in the lab, how to manipulate the bandwidth and all. So I will do that.
Okay, sir. Thank you.
Now, guys, we have the one concept that always going to like confuse to engineer that give me 1 second. Give me 1 second, guys. That is always going to confuse everyone. That is the two terms. So one is the RD and another is the AD. Both are same. Okay, don't be confused. Your FD is difference. FD is feasible distance. Feasible distance is the total metric or best path. That is clear. But if I'm talking the RD is the reported distance. And AD is also known as the advertised distance. So how it is going to be understand? What is the meaning of the reported distance and what is the meaning of the advertised? So both are same. There's no difference between the RD and AD. So if you know, go and find this on the Google for your just awareness purpose. In EIGRP, AD and RD are same. Advertisers and advertiser. Okay. No. That is something they RD. Okay, let me see that. Hold on, guys. It's making me confused as well. Hold on 1 minute. Oh, this is same. Okay, let me find in the book why this is showing like that. So, okay, let me put in different way. What is advertised distance in EIGRP and what is reported distance in EIGRP? See, so sometime even AI is also confused you. Okay, earlier when I asked, are they same? So they said no, they are totally different. So don't trust on the AI sometime. So now they are saying that exact same values, right? So don't be confused. Somebody is doing the AD and somebody is doing the RD. So you don't confuse. Both are same. So in both scenario, what is going to happen means the definition, the reported distance or advertised distance, the metric reported by your neighbor means if you have the multiple path, right? So all neighbor are going to report your metric for any destinations. Means your friends, some neighbor are going to tell about your destinations. Means if you are, let's suppose, in this location and he want to know what is your metric from this location to this locations. So you are going to report the metric that is known as your feasible distance. Reported distance, not feasible distance. So reported distance is basically advertised distance is just metric reported by your neighbor. So if I find one of the analogy on the internet, let me GRP feasible condition. Let me find one of the image so I can show you in the better way. I need to draw, but let me find in the image in the Google. Or let me see in slide I have something or not. Feasible condition. Let me go here. Okay, so okay, I will talk this later. Okay, I will come here, but let me show on the Google. So see, this is the feasible conditions. So you can see this is your this is the R4 route. This R4 route is receiving some kind of the update from there. So this update means for this router point, you think about that. This route update is going to advertise by this neighbor. Okay, this is going to report your metric for this destination. And this is also going to advertise by your neighbor. So this router will receive two updates. they both are going to report what is my metric of same destination 9.9.9.0. So that is the neighbors are going to report my metric of the destination prefix, that is known as the reported distance. Okay, clear? So what is reported distance? Reported distance is nothing. Your neighbor are going to report some sort of the metric information about destination route. That is the reported distance or advertised distance. Now, the next one is going to be difficult. There is a feasible conditions. So there is a feasible distance, right? That is one thing. Reported distance, advertised distance, another things. And now third thing is going to be your feasible condition. So what is the feasible conditions? So feasible conditions have the formula. Your reported distance always should be lesser than your feasible distance. What does mean? Does mean any destination route you're going to reach from any source to destination, they already have the feasible success, means feasible distance they have. Feasible distance is the best metric they have. So your reported distance should means to become a feasible, means you want to become a my backup route. These feasible conditions are going to use to select the backup route. And backup route, if there is a already have the higher metric, how you can become my backup route? You're never going to become my backup route. So your distance must be lesser than my total metric distance. So if my total matrix is 1000 and you reporting me 1500, so I will not consider as a backup route if I have something better than you in my table. So your distance must be lesser than my total matrix. So that is a feasible condition to get the backup route. So for a route to be considered as a feasible successor as a backup route, they have to meet the feasible condition. Feasible condition says that whatever your neighbor is reporting the distance, that distance must be lesser than the total metric, total distance. So that's why a neighbor RD must be less than your FD to get the best path or might be the backup path. So there is some kind of an analogy they're talking about that. So just ignore that. But yes, this is how it is going to happen. And in this topology, we are going to find that you are going to get that feasible conditions like this is reporting this is reporting this, and this is like that. So this particular RD total, this one, and FD, he is reporting like 58 something, and he is reporting like something 48 something. So it's not going to be meet the feasible condition, then your route is going to be discarded. So I'm not going to read these all things, but this is the whole concept is going to happen for your feasible conditions. So if you go in the book as well, and you see here, reported distance reported by your router, means that neighbor router to reach the prefix. Reported distance value is the feasible distance for the advertised router. And feasible conditions, you know that routes to be considered the backup route. Feasible condition router considered backup route. RD received for route must be less than the FD value. Means reported distance must be less than your FD. That is considered the backup route to build the loop free topology. So you should know these all: successor route, successor, feasible distance, reported distance, feasible condition, and feasible successor. Feasible successor backup route. And to calculate the feasible successor route, you must have to meet the feasible condition. I hope it's good to all, and we can proceed the next step. Now you see a successor path, best path, fastest route, feasible is a backup path, feasible distance, total path cost, reported distance, neighbor advertised cost to your all neighbor is going to advertise that. Feasible condition just to use to select the best path, and your feasible condition, your reported distance must be lesser than the total feasible distance. Okay, so that's conclude the module 2 as well. All right. Now let me open the new thing in EIGRP, and we'll go and do the configuration after that. Let me go in the NRC. Okay. So the module 3 is all about your metric calculations. How we can calculate the metric, how we can define the formula and all. So as I mentioned that EIGRP is going to leverage the metric, and that is the composite metric. So that composite matrix is going to be basically your K1, K2, K3, K4, K5, and that support up to, if you just want to build the EIGRP, it support up to maximum 255 hops. That is the max limitations. And because why 255 hop is always, it's a maximum. After that, you cannot reach that. But you can just increase and decrease if needed. Now, if you're going to configure the EIGRP, the metric is the parameters. Based on that, you can calculate your best route, the successors, feasible successors, and also you can do the feasible conditions. So if you want to do any successor route configuration, you want to do the feasible routes, feasible successor route definitions. So you have to use this metric, and without this metric, this cannot be calculated. The value I was showing earlier, this all is coming due to the metric. This is the metric. And successor, feasible successor, this all coming from the this value only. See, this all values coming from the your EIGRP metric calculations. So if I want to manipulate anything, you must have to use this metric. So by default, you have the K1, K2, K3, K4, and K5 value. So K1 is going to represent your bandwidth, K2 is going to represent your load, K3 is going to represent your delay, and K5 is going to be your reliability, and K4 is reliability, and K5 is a bandwidth. Okay, so might be bandwidth is not here, but no, hold on, something wrong. Wait. Okay, so MTU, sorry, K1 is bandwidth, K2 is load, K3 is delay, K4 is reliability, K5 is MTU. So somehow MTU is missing here. I should need to write here. So MTU. So what is this all parameter? What is the bandwidth? The bandwidth is a link bandwidth. Means any interface you're configuring. So you must have bandwidth on the link. How to check the bandwidth? Anyone know that? If I want to check the link bandwidth, how can I check that for this link? How much bandwidth I have? Anyone idea?
The show interface status will find.
Show interface status.
Oh, sorry. The interface type actually, which you already typed in last time.
Okay, so this one is status.
No, not the status, sir. That's it.
Okay.
Yeah.
So what is the bandwidth for this link? Have you configured any bandwidth or not?
Here we haven't configured. I think it's a 1 Gbps.
kbps.
So it's a 10 Mbps. No, sorry, 100 Mbps. 100 Mbps. Yes, it's a Ethernet, so 100 Mbps. Gig is going to be 1000 Mbps.
Yeah.
So by default, this is your bandwidth. And you can see by default, this having the all 5 parameters, whatever you're seeing in the slide now. See, bandwidth, load, delay, reliability, and MTU.
I'm sorry, sir. How much you said it's the bandwidth hit is
100 Mbps.
That's 10,000 kbps, sir. So that should be
Let me
not 100.
calculate it.
That should not be 100.
Okay, this is Ethernet, no? Okay, this is Ethernet, so 10
Yeah.
Mbps. So yeah, right. It's
Yeah,
Ethernet,
10, yeah.
it's not fast Ethernet. So sorry, it's 10 Mbps only. Sorry. Thanks, Akhil.
Yes, sir.
I would think it's a
Yes,
fast
sir.
Ethernet. Yeah, so it's going to be your 10 Mbps guys only. Okay, so if you
Yeah.
want to calculate, so you can calculate only.
Sir, I'm
Fast
only
Ethernet is going to be
I'm only your student. You know this.
Thank you.
Yes, sir. Thank you, sir.
Okay. 10 Mbps, you're right. So the link is Ethernet. Ethernet by default 10, fast is 100, and gig is 1000. So I just missed this statement. Sakil corrected me, my good friend. All right. So you can see all
I'm
5.
your assistant.
Yeah. So all 5 values, you can see K1, K2, K3, K4, K5, that all are available here. So if I just go with the MTU is going to, let me go in this slide, MTU is going to represent your K5 value. People learn that, but they never see these values, okay? So they know theoretically, but you can see this value. MTU is here. This is going to represent your K5. If I want to go and see that K2 value, that is a load. What is a load? You can see that is the load. This is the TXRX load. So this load is how much load on the circuits. Based on this load, they calculate some metric. Now, the next is the delay. Is there any delay of your circuits? So this is a delay. How much delay? So this is going to be 1000 microseconds. Okay. So if you just calculate this into seconds, so you get, this is a delay. Means any packet is coming, so almost 0.0001% delay is there. Means this is a microsecond. So this is a delay of particular this circuit. What else? Reliability. So reliability is going to be this. Have you guys ever seen reliability is getting low or high? It's high or low?
Yes,
What? It's high or
it's
high,
correct
low,
only.
normal.
It's high.
Normal.
Normal. So
Yeah.
it could be high or it could be low. What is possible?
It's 100%.
This is a high 100%.
Yes, it should be 100%. If you see, so which value, left side or right value? Which value should be going to create a problem?
Left side.
Left side. So if you guys find any value less than 255, you think
Yes.
there is some issue in my circuit. Okay.
Yes.
So reliability should be always 255/255 for your circuits. This reliability also help to calculate your metric, right? And going further, and last one is the MTU. Sorry, Sai, what is the question?
Nothing,
MTU
sir.
we
Okay.
discussed? Okay. The bandwidth, we already discussed load, delay, reliability, and MTU. So we have the all parameters available here. And you guys see that. Based on these parameters, EIGRP calculate the metric. So if you want to include all 5 parameters, you can include. If you don't want to include, you can just go with default. If you are going with default, in that case, what is going to be happen? By default, bandwidth is going to be in consideration to calculate the metric, and delay is going to be calculate the metric. Rest are going to be 0, 0, 0. Means the reliability is not going to be considered, MTU is not going to be considered, and load is not going to be considered. These all 3 values are not going to be considered to calculate the metric. So you are going to only consider bandwidth and delay. So this value is going to be used for metric calculation, and this is going to be used for the metric calculation. Rest are going to be ignored. And how to check? So if you want to check, you run the command 𝗀IP protocol. In that case, you're going to get that 𝗀IP protocol and click enter. And you see this EIGRP running, and this is the metric. And you see right now K1 is set to 1, K2 set to 0, K3 set to 1. So K1 represent your bandwidth. This K3 is your delay. Rest 𝗵5 reliability, MTU reliability, and your what is the next one? Sorry, I forgot. Load. These all are going to be ignored. So that's why your bandwidth is getting calculated on these 2 parameters only. Clear? So bandwidth and delay, and that's why you're getting the total metric for the any case. So based on this parameter, they're going to calculate the metric. So this is the same thing they are talking about. So let me back to the original slide. So EIGRP is going to be calculated the metric based on composite metric. They utilize by default bandwidth and delay. If your link is going to be slower, right, your bandwidth is going to be less than your metric is going to be. So definitely bandwidth is lesser than your link is going to be slow, and metric is going to be higher. If bandwidth is going to be higher than your, definitely your load is going to be means not load, your metric is going to be lower. So probably we have some table as well. So you can see here. So this is a table. If you have this link, serial link 64 kbps, you have the more delay, and link is slower, you have the more delay, your metric is very high. You have the T1 circuits, your link is little higher than this one, so your delays remain same. You have the metric is little lower, right? Ethernet you go, you have this metric. If you go fast Ethernet, this metric. If you go for the any gigabit Ethernet, this metric. 10 gigabit Ethernet, this metric. So you can see you are getting the metric lower in case of you have the higher bandwidth. This is the last matrix, okay? In normal classic EIGRP configurations. Enhanced EIGRP configuration, we'll see even we can use the K6 value. K6 is basically used for the, even you want to get precise metric, Not only, let's suppose you have one link as a 10 GPS, one link is my 20 GPS, both having the same matrix because we cannot lower down the matrix more than 5 and 2, but that's not fair. One link is 100 Mbps, 100 GPS, one is 10 GPS, both have the same matrix. So to just overcome that problem, we have the K6 value. Later probably we'll see that. Let me see if I have that matrix. So we have the K6 value. Yeah, see, this is a K6 value. Okay, so this is known as a wide matrix. So wide matrix is basically if you have the higher bandwidth link and you're not able to do the fair matrix calculations, because this is a limitation of the classic matrix. This is the classic matrix. Classic matrix is maximum. If you have the 10 GPS link, you get the 5 and 2. If you have the 20, even 5 and 2. 100, even 5 and 2. So anything more than 1 GPS, your matrix is going to be same. So it's not fair deal. Okay. So to overcome this problem, we use the K6 value. K6 value, this is the classic matrix calculations. This is cannot go beyond the 10 GPS. Means matrix is going to be same for the all 10 GPS link. With modern networks having the 40 GPS link, 100 GPS link, 1000 GPS link. So how you are going to do the fair justification for those kind of the links? So to overcome this problem, we use the wide matrix. Wide matrix use the extended K6 value to just calculate the precision based your bandwidth calculation. So they measure the matrix with the K6 value. So if you're using the wide matrix, I'll configure, I'll show you how to use that. Then we'll find that. So let me back to the again, and then we'll conclude this one by one. So bandwidth is going to be calculated based on the link type. Delay is going to also predefine, and the matrix is going to be this. So slower bandwidth you have in the higher matrix. Higher bandwidth you have the lower matrix. And this is the formula. So this is going to use the delay and by default bandwidth. And this K value range is going to be between this 0 to 255, and component writing the K1, K2, practice, never requirement is all going to be used K value, and this is the default, and you can check that. I just showed you how to check this informations, and this is known as a classic matrix. Means if you just do the bandwidth calculation, this is the formula you have to use. That means 256 into 1 into multiplication. So this value is going to be means whatever the minimum bandwidth you have linked 10 to the power 7. So this is going to be your positive value, this is going to be 0, this is going to be 0, and this is going to be your positive value. So these two parameters, technically your matrix is going to be 256 into 1 into 10 to the power 7 into your reference bandwidth, minimum bandwidth, plus 1 into total delay divided by 10, and whatever the value is going to come, that is going to be your matrix. Rest, this is 0, this is 0. So you cannot use this formula. So this is a final matrix formula. This is the matrix. So if you're going to calculate the matrix in classic way, you are going to get this final formula 256 into 10 to the power 7 and minimum linked bandwidth. What is the minimum linked bandwidth? This is also very important thing, guys. When you're configuring the any link, so it's very important to understand what is the minimum link bandwidth. So this is the R1, this is the R2, this is the R3, this is the R4. Now, this link is your 1 Gbps. This link is your fast Ethernet. Okay, let's suppose you're running the loud 4.4.4.4. So now if this route is going to reach, let's suppose from this path. Okay, so how it is going to calculate the matrix? There is a 1 GPS for this matrix. Let's suppose if I'm going to use this particular documentations. So 1 GPS link, we have the matrix is 2846, but fast Ethernet we have the 28160. So which value I can take for this link? Any guess? This one or this one? Because these links are not same. When the packet is coming from there, some links are going to be fast Ethernet, some are going to be your 1 GPS. So for this route, if I want to calculate the matrix, what is my matrix? So how this router is going to calculate the matrix? Any guess? This will take the lowest fast. It will take the same meaning they are talking about that. So it's very important. Always you have to remember, whenever you're going to define this bandwidth and all, you have to remember minimum bandwidth means whatever packet is coming from the path. What is the minimum bandwidth? If all link have the same bandwidth, then fine. But if bandwidth is going to be low down for any region, that is going to be problem for you. And you have to always use the minimum bandwidth to do that configurations. Sakil, anything?
So, sir, yes, sir. If you can go back to the diagram that you just draw.
Okay, let me go. Okay.
Oh, you erased it. Oh yeah, this one.
Okay.
So okay, so router 2 is actually when sending when advertising to router 1, it will advertise the bandwidth
Metric
between router 2 and router 4.
Yes, that means basically the metric will this router report the metric to this one. So this will calculate the metric based on this, and this will add this metric this one as well. So whole metric is going to consider this one as a lower metric. This will report what is the metric for me. Okay.
Okay.
And based on that, this is going to calculate the metric, and it's fine that the metric I'm receiving, based on that, this information is going to be there. That link is slower link because they are getting the higher metric because they have the all OS information. Which link is higher, which link is slower to me.
Yes. Okay. Yes, sir. Thank you.
All right. So moving further. So you can see bandwidth component use the slowest link in the path. That's very important. Always when going to configure the bandwidth, it's going to be always slowest, and sum is going to be your total delay or what is going to happen. And this is your general for the classic metric. Now this is the table. You have to remember. Yes, Amrita?
Go back to your diagram, sir, once again. I have one doubt.
Yeah, please ask.
The diagram. For example, R2 and R4 is also 1 Gbps. From R1 to R3, fast Ethernet 100 Mbps, then R3 to R4 100 Mbps. In this case, which route is preferred?
Definitely, they will give the two routes. This is going to one low metric route here, and this is going to be the high metric here, right? So this is going to prefer.
Yes.
This is low metric, no?
But in distance vectors perspective, it is also considered as a hop count as well, right? So here the
distance vector body is not going to use the, sorry,
here
Amrita?
it's calculated 3 hop count. Here it's, I am audible, sir?
Yeah, you're audible.
Hello?
Yeah, please go ahead. Go ahead, Amrita. You're audible.
Sir, add another one route. Add another one route also here. See R2, R3, R4.
One here ahead.
From R1 to no. Between R2 and R3. Say R4. R2 and R4 in the middle.
Here, you want to add something?
No, sir. Between R3 and R4. R3 and R4.
Okay. Okay.
So here R1 and R3 1 Gbps and R3 R6 1 Gbps, R6 R 1 Gbps. Here 100 Mbps. R1 R2. Sorry, here 100 Mbps.
Okay.
Here 100, 1 Gbps 100. Here 1 Gbps, the second alternative, 1 Gbps. So which route is preferred? Actually, here it's R1, R3, R6, R4. There is multiple hop count, right? Here only one, like, so which route is preferred?
Technically, this will prefer. This is as per the, we'll check in the lab also. This is going to prefer technically because of lower metric. Hop count is not going to be considered in the, they support the hop count, okay? They support, see, understand, the metric of EIGRP is not hop count, okay? You understand this concept, Amrita? Note this word.
Okay.
Metric of EIGRP is not hop count.
Yes,
metric of EIGRP is your composite metric, okay? So hop count is something, means EIGRP support up to 255 hop count, means up to your packet is going to travel up to 255 hop counts. That is a one concept, means how many hop count my packet can be travel. Make sense? By default it's 100, but you can configure EIGRP up to 255 hop count, but this is not your metric.
Okay.
If this is a RIP, okay, then definitely this is going to be your best path. In regard to the slower bandwidth, higher bandwidth, doesn't matter for you. If this is slow bandwidth even, this is going to be your become best path. But in EIGRP, this is not going to be your best path. This is going to be your best path because this is going to calculate based on the metric, and metric is lower.
Okay, sir. Why I am asking, like, because like it's bandwidth and delay, right? Oh, okay. Sorry, sir. It's right. You are right only, sir.
No,
It
it might be I'm wrong. Sakil, what do you think, guys? Sakil, Mr. Sakil, you want to put some light?
Yes, sir. Yes, sir. Yes, sir. Okay,
correct
hop
or-
count is yes, hop count is never calculated in best path calculation based on the metric. It's never a part of the metric calculation.
Right.
Hop count is never a part of metric calculation.
In EIGRP.
Yeah. This is what we're discussing. So metric is K1, K2, K3, K4, K5, and all these from 1 to 5. There is no hop count.
Right. Okay, Amrita. Good questions. No problem.
Does it make sense? Yeah.
Yes,
It's just a feature that should not be more than 100 or 255, but it's not a part of best path calculation or backup path calculation. It is never calculated in the algorithm.
All right. Amrita, makes
Thank you,
sense to
Sakil.
you? Okay. Yeah.
Yeah.
Thank you,
Yes,
Sakil.
sir. Yes, sir.
Appreciate it, everyone. Please take a note. It's a good question, by the way. It's a very good question. Might be people going to be confused.
Yes, that is true. I had this question one time when I was a little boy.
No problem. All right. So, okay. So we are good till here. Now, these are the matrix. So I was talking about the, this is the normal calculation matrix and all. And now we have another matrix. This is the classic. Whatever discussion we have done, that is a classic matrix. And this classic matrix having a problem with the delay precisions. Means they can measure delay up to 10 microseconds. That is the lowest delay measurement, 10 microseconds. You can see any link greater than 1 GPS or 10 GPS, they not have the better precision for delay. Always it is going to become as a my 10 microsecond. But let's suppose I have the higher bandwidth link. So that's unfair, like for them. If I have 30 Mbps, 30 GPS, 40 GPS, 100 GPS, so not going to be your good measurement. So bandwidth measurement measured in the KPS, which not scalable in the modern high-speed network. Delay precision measured in a 10 microsecond increment, lacking the precision of today networks. Modern network cannot properly represent speed beyond 10 GPS, which are increasing commonly. They are increasing nowadays. So Cisco developed the one different matrix that is known as the wide matrix. In this wide matrix, they introduced the K6 value. So EIGRP wide matrix address the scalability limitation classic matrix, adding the K6 value, which is going to measure jitter energy, means whatever loss, latency, jitter in your link. Based on the jitter energy, based on that, they are going to scale up to 655 TBPS links as well. Means it is going to calculate exact matrix even you have the up to 655 TBPS link available in network based on the picoseconds rather than the microseconds. So delay is going to measure in the picoseconds in the wide matrix. They use the K6 value, and you can see this is my GUINET lab. I have taken the snapshot for the reference only. You can see. So this is the GUINET lab, and this GUINET lab we are creating this some EIGRP. I configure that, and based on that you can see these are the picoseconds they are going to be used for the bandwidth calculations, and you are going to get this K6 value here. Okay. So that's why I designed this slide. So at least I can show you. So when I'm going to configure these all things, so you guys will understand how this is going to be there. So this is your wide matrix. And if I do the calculations for the classic matrix for the wide matrix, so you can see this size is 32 bits. This size is going to be 64 bit. This is going to just support for the IPv4, but this is going to support for the IPv6 and IPv4. So if you're using the any IPv6 configurations, you cannot use the classic matrix. You can always use the wide matrix. This can support only the number base, like you can do that. And this can be named number both. You can just use that. And this can limit it to the 10 GPS for your all bandwidth calculation. This can be for the precise matrix for the interface up to 655 Tbps as well. So probably you're going to find this enhanced method of doing the bandwidth calculation and matrix calculation for the EIGRP. So this is the EIGRP matrix calculations, and this is a formula, and that's all, right? So we have to do now configurations, how the configuration is going to happen, how the deployment is going to happen. But yes, we have to do a lot of things, right? Definitely in EIGRP, we have a lot of chapters. We have to understand the authentication, stub routers, inactive. We have the summarization, equal, unequal. Like we have a lot of things to discuss. So now the next step, what I can do that, we'll do the more configurations. In this configuration, what I'll design this topology as well. And this topology will try to play with some metric. So let's suppose that let's have some time. Let's configure this topology for the future reference. So I will play with the top. Let's suppose I will increase some bandwidth, decrease some bandwidth, and see how the metric is going to be available for different link for different source and different destinations. So we use that as well. So let me just set up this lab. This is going to be 161600000/24. So let me make this one. I will use this one as well. This is going to be your 1400000, sorry, 00000/24. Let me configure this one as well. I can go for 1313. So I'm just giving the network identification. So we should know which network is going to use for what purpose. Okay. This is not needed now. I can just remove this. This is not needed. I can just remove this. This is not needed. I can just remove this. I can just make the new topology. Let me edit it. I'll make as a it's going to be 12000/24. This is going to be my 170/24. Okay, now I'll go and configure there as well. This is going to be my 56. Okay, 0/24. This is 5, this is 6, 56. This I'm going to make as a 46000/24. This is going to be your 350000/24. Okay. 35, and this is going to be my 25. And this is going to my last one is going to be 75. Sorry, 57000/24. So we are going to use this for the all matrix. This topology we are going to use for the all matrix calculation, guys. So let me turn on. I'll not configure the whole topology. We'll just turn on the router and we'll just save this for the next lab. So I just want to save some time in the next class. So let me do some. This is going to be there. This is going to be there. Okay. So going in here, and let me write the configuration. Enable config C, right? I'll just save as a host name. Host name is going to be 𝗲𝗏 and do right. Let me go here as well. Configuration. And I will just put the host name 𝗲𝗏6 and do right. Okay. Now moving here. Configuration host name 𝗲𝗏4 do right. Configuration host name 𝗵𝗊3 do right. Configuration hostname 𝗵𝗊true do right. So let me do for this one. Meanwhile, that is booting. Hostname 𝗵𝗊5 do right and enable configuration hostname do right. Okay. So I will do the next configuration in next class because already we completed 2 hours. So I don't want to extend the class. Okay. So in next class, what I'll do that. Whatever we do the matrix discussion, calculation, so we'll use one of the use case and we'll build the EIGRP. We'll try to see how the successor, feasible distance, all going to look like. And at the same time, how we can manipulate the matrix on the interface, and based on the matrix manipulations, how the calculation is going to happen. So that's all for today, guys. I hope you all enjoy the today's session for the EIGRP. Like we discussed,
Yes,
2-3
sir.
model. Yeah.
Yes, sir. Thank you very much.
Thank you, everyone. See you again. And the class timing 9:30. Now onward is going to happen IST time. So check your local time. So India time is going to be Saturday, Sunday, 9:30 IST. For India, Saturday, Sunday. Okay. So what is the time in US today? Is Friday morning or what?
It's my central time. It's 11 p.m.
Saturday or Sunday? What?
Friday and Saturday.
Okay. So for US, what time right now?
For US, yeah, for US Central Time, 11 p.m. Friday and Saturday.
11 p.m. right?
Yes, sir.
So 9:30 equal to 11 p.m. right?
Yes, sir. 9:30 is equivalent to 11 p.m. Friday and Saturday.
Okay. So that's, I believe, avoid the confusion. Special to one for you. Okay. I believe sometimes you also confuse. So just take a note or you convert this time 9:30 IST Saturday, Sunday. And for you, it's going to be 11 p.m. Saturday, Sunday. As Sakil is also in the US.
That's Central Time, US. Because we
yes,
have
Central Time. Okay. Okay, yeah. Central Time. Okay, got it. Yes, US have the multiple time zone. Yeah, got it.
Yes.
Sir, I have one more doubt, the 5 one. And
yes.
the K, as you said, the K calculations may vary based on the routing protocol, but the K termination will be the same or the different?
No,
The
this K
process how
is
we
only for
have.
the EIGRP. K is only for the EIGRP. OSPF have
Okay,
different
okay.
metric calculation. BGP have the different metric calculations. Okay. K is only for the
Okay, okay.
EIGRP, not for the all routing protocol.
Got it, sir.
All right. Thank you, Sai. Chalo. We'll see you
Thank you,
again
sir.
next class. Bye. Take care, guys, everyone. Thank you.
Take care.
Thank you, sir.
Bye-bye.